SwayamPrabha. Digital India. Educated India.
Welcome back. In module 4 we will be talking about pumping and storage, and in lecture 16 we will be explaining pumping stations. The different concepts that will be covered in this particular lecture are on lifting of water, pumping stations, site selection for pumping stations, and setting or sizing of pumps. So, in the last module we have talked about different kind of intakes, both groundwater intakes as well as surface water intakes, and when we have talked about them, we have also discussed about that there may be certain, in some cases we will require a pump to lift the water from a sump well and then send it to a treatment plant. So, that was the first indication that pumps are required in a water supply or even in sewerage networks. Now, in water supply systems, there could be different types of ways we can organize the system. For example, in this particular slide, you can see 4 set of images explaining different forms we can set up a distribution system. For example, when in the first case, when no lift is required using surface sources, that means lifting of water is required using from surface sources. So, we see that at here we have the river or lake or the impounding reservoir at high elevation. So, already the reservoir or the water body is at a higher elevation. So, because of gravity, water will flow from that particular elevation to lower elevations, or you can say that already there is higher pressure in that particular that flow, and through these pipelines or pressure conduits, because water supply water flows in a pressure, so we call them pressure conduits instead of gravity flow. And then in pressure conduits, because there is some amount of pressure because of the height of that particular water body, the water automatically reaches the treatment plant, from where it can be sent to a service reservoir and from there to the distribution system. Now, this is with the assumption that the water body is above the treatment plant and the treatment plant is above the service reservoir. So, there is no requirement for pumps to lift the water, but it is not always the case. In most cases, we have to lift the water. For example, there could be a case when only one lift is required, and that is also whenever we are using water from a surface water source like a river or a lake or a reservoir, then the water may be already at a higher level, from where we can pump the water to, or not pump, sorry, we can send the water to a treatment plant, and from the treatment plant, and then we want to lift the water to a service reservoir. And the reason for lifting the water is because we are taking the water up. Now, if we connect a distribution network, that means a network of houses connected with pipelines, then from this service reservoir or overhead tank, the water will automatically flow into this particular distribution system. So, that means there has to be some way to lift the water from the treatment plant, which is usually at the ground level, to this overhead tank or service reservoir, and this is where we actually require a high lift pump. That means, we will set up a pumping system or a pumping station to lift this entire water. Every day the pump has to be run, maybe during the morning or during the evening, depending on how you decide on the supply of water, and this high lift pumps would operate and lift the water to the service reservoir, from where it could be distributed. Similarly, we can also do it in something like wherever there is a groundwater source, like for example, there is a deep tube well. In that case, we also use a pump to actually lift the water, but this is a low lift pump, because you do not need to lift the water for too much head, or in this particular case the total amount of head would not be that high. So, we call it a low lift pump, and from there the water is sent to the treatment plant, because again the treatment plant is at ground level and we can send the water there. So, and usually the treatment plant is nearby, and once we have sent the water, from there again we have to lift the water to a service reservoir using a high lift pump, right. So, the rest of the system is more or less similar. And finally, where we have got two lifts similar to this one, but in this case the pump was directly lifting the water from the tube well, but we can always have another surface water source, and in this case if the surface water source is at a lower level compared to the treatment plant, we have to use one pump over here, and then once from using intake conduits, the water is first brought to the pump, and from pump we are actually putting we are creating the pressure in the water, and we are sending the water through pressure conduits to the treatment plant, from where again a high lift pump is used to actually lift the water to a overhead reservoir, and then finally to the distribution network. So, this is more or less the places or the positions where pumps are required. In addition to this, we also require pumps in other situations. I will talk about that. So, let us look at where we need to put the pumps. So, first of all, to summarize whatever we have been discussing, pumps are required for lifting water from a river. Most probably the lift is something around 2 to 20 meters lift, not more than that, and or for lifting water from a well. And here we lift high quantity of water, but the pressure is low. We don't need too much pressure in the this water. Or we want to lift water inside a treatment plant. So, if a treatment plant has got several processes, maybe sedimentation, then coagulation, and then so many other processes. So, there may be between the, and if the treatment plant is set up in a undulating terrain, we may need to even lift the water within the treatment plant. And sometimes when we use rapid gravity filters also, we have to lift the water a little bit up and then allow the water to flow down. So, in that case also we need to lift the water. So, that is also where some pumps are also may be required. So, then for pumping water into the distribution system, so this is the high lift pump that we discussed already. And finally, to boost pressure within the distribution system. So, what happens, sometimes there is a overhead reservoir, and the overhead reservoir is raised to a certain height. The heights could be different based on the pressure requirements or the distance water has to travel, overcoming friction and other things, and based on that we will give a height to this overhead tank. But even then what happens, gradually the surrounding neighborhood grows or the surrounding zone grows, and we need to provide water to further and further distances. So, in that case we will see at the furthest end the overhead pressure is actually the pressure in the pipe water is actually coming down, or it is below the standards. So, that is where again we want to we will put a pump in the system to boost the pressure. That means, the work of this pump is just to take the water and then increase its pressure, right. So, that is where the water will come to a sump over there, and then it will again pump the water back into the system, and that actually increases pressure in the system. And so, these are called boost pumps. So, this kind of pumps are also there in the system. So, these are called boosting stations, pumping stations and boosting stations. So, when we talk about pumping stations, main pumping station supplies water to the distribution system, and usually these are located near water treatment facility or a potable water storage facility. So, we have to decide if we should keep this main pump or this high lift pump near the water treatment plant or near the overhead tank. So, we can put it anywhere. So, what it means is, first of all you have to, in both cases we require a pump, and the location of the pump actually is determined by looking into the different properties or the characteristics of that particular situation. For example, how far away is the distance between the storage reservoir and the treatment plant, where we have land available, and then what kind of pressure is required, and depending on so many things we actually, and what is the terrain of that particular space, depending on all these things we decide the location of our this pumping station. But it could be either near the water treatment facility or towards the water storage facility. So, because you can put the pump anywhere in the pipeline. So, high lift pump we already discussed, pumps which pumps directly into the distribution system, and the pumping station may be part of other structures. That means it could be part of in a treatment unit itself. We can have a pumping station which actually pumps the water from the treatment to the overhead reservoir, or along with the overhead tank we also have a pumping station. Both kind of systems are possible. And then we have got booster pumps which increases pressure, and they could be located anywhere in the pipeline. That means they could be located in the middle of the pipeline as well. And usually we will find this at areas with topographical differences. Or why topographical differences? Because suddenly within my area where my overhead tank is actually serving or distributing the water, we will see that there is a mound. So, that means, and there are houses on this mound as well. Mound means a small hill, right. So, there we can see that we need to increase the pressure, but if we have designed my overhead tank where this extra pressure has to be taken care of, then probably the entire thing would not be economical. So, instead I put a small boosting pumping station at this particular zone and pump the water up into this particular mound, or this into the buildings of this, into the network that we designed for this particular mound. So, that means so boosting stations are required wherever there are some terrain issues, or during peak hours when flow requirement is more. That means during peak hours what happens, everybody is opening using the tap at the same point of time. So, there is huge amount of flow that is required at that point, and that also results in dropping of the pressure. So, that is also when we need to run this kind of pump to actually boost the pressure inside that particular of water in the network. So, these are the two time or the two conditions when we actually use a booster pump. And booster pumps could be added to an existing installation. So, what it means is we have a overhead tank, we have a fixed network, then we expand the network, we can use a booster pump there to help in expansion of the network. And based on present and future demand requirements, so in future demand is more, then we probably have to add a booster pump, and it adds on positive heads to the pump suction. So, that is understood. So, pumping stations similar to this water supply networks, we also have pumping stations in the sewerage networks as well. So, it is the same principle, same all the things related with pumping stations are more or less same. Only thing is one handles water supplies, it could be raw water or fresh water supply or potable water supply from treatment plants. Similarly, for sewage it could be storm water, or it could be pumping of storm water, or it could be pumping of the raw sewage as well. So, pumping stations are required within the network for lifting sewage to a certain height, of course, and in most cases what happens, sometimes the sewerage system or the network of sewerage pipelines, there could be shallow sewers. Now, what shallow sewers means is, because of certain issues we have to lay the pipelines at a upper level. So, usually in municipal slums and all, you will find that the sewerage network is at a higher level. So, it is a shallow sewer network. So, there we have to probably lift the sewage from this shallow sewer, and if we want to lift the sewage from the existing sewerage network into this shallow sewer system, then we have to actually use a pump. And for conveying to the STP or the outfall, that means sometimes the sewage treatment plant STP, or the outfall means the outfall of sewage into the river, wherever sewage comes out of the pipeline and drops into the water bodies. So, that is called an outfall, and in this particular cases sometimes these are at a higher level. So, because sometimes the river bank is at a higher level and we actually want to lift the sewage up. In that case, particularly for conveying to STP or outfall, we actually we use these lifting stations. For low-lying areas to existing sewerage infrastructure, so that means similar to when in case of water supply networks, we have to lift the water up to in case there was a mound or a elevated area. Similarly, if there is a low-lying area and we want to lift the sewage up from this area to the main lifting station, then also to the main sewerage network, then also we need to have this pumping station which will actually lift the sewage. And finally, for remote areas not linked with the sewerage network, we also may use this pumping station to actually boost the sewage and connect it to the sewerage network or send it to the sewerage network using pipelines. So, this is where we actually require pumps both in the water supply and in the sewage network. So, coming back to water supply networks, usually pumping stations are of different kinds, as I was saying that it could be at high lift pumping station, or could be a low lift pumping stations required at the source. That means wherever you are lifting water from surface water sources or groundwater sources. So, as you can see in this particular case, in water supply networks, sometimes the intakes or the points from where we draw water is far away from the area which we serve. So, these are located at remote areas, right, and thus water needs to be pumped for great distances to the treatment plant. So, in that case also we need to have very big pumping stations or high pressure pumping stations to pump the water using this kind of pipelines. As you can see that this is a MS water supply pipeline for Delhi, and this is 2420 mm in diameter. So, that is around 2 meters diameter. So, you can see the image, and similarly this one is the pipeline which brings water from the Kadak-Vasla Dam in Pune for the Pune city, right. So, this kind of pipelines are laid from the intake sources to the treatment units, or if the treatment is done already at the area where the water is being lifted, from there to the main city using this kind of pipelines, and there also we require large pumping stations to send the water across these distances, right. So, let us see in case of Delhi, you see water is being taken from Tehri Dam, and this is almost like 320 kilometers away. So, this is not the entire the water source, there are other sources of course, but this is one of the sources. And similarly in Mumbai, we get the water from Middle Vaitarna Dam, which is around 120 kilometers away. And then we can get, in case of Chennai, the water is taken from Krishna river, that is around 200 kilometers away. Bangalore from Kaveri river, that is around 100 kilometers away. Hyderabad, that is from Krishna river, that is 100 kilometers away, and Bhopal around 70 kilometers away from the Narmada river. So, this is also where we actually use pumping stations to send the water across these great distances. Now, how do we select this location for pumping station? Of course, as we were discussing, it should be either near the treatment unit or it could be near the overhead reservoir. But how do we select a site? So, of course, first criteria is availability of space. So, in most cases, because these are infrastructure made by government departments or the government itself, so that is why probably wherever government land is available, we will actually develop this kind of pumping stations. So, but it is not exactly, sometimes we have to also acquire land for that. For example, if I locate a overhead reservoir and I want the pumping stations along with that, in that particular case I will require the overhead reservoir to be as central as possible to the area it serves. So, of course, we have to find land over in that particular area, but there has to be certain basic criteria that has to be followed. For example, of course, it depends on the location of the place from where water is received and water is supplied. So, based on that, we have to, that is the first criteria of course, and it has to be because we are dealing with both water supply as well as storage networks. Pumping stations are required for both. You have to be careful that it has to be away from sources of pollution and contamination. That means, in case of some event where rainfall, heavy rainfall, there is flow or runoff from one zone to another, there may be polluted water will get mixed with the treated water. So, to prevent those kind of things, it should be away from pollution and contamination. It should be above the highest flood level. The reason is again, particularly in case it is adjacent to a river. The reason is, in case of flood, maybe again water will flow back into the pumping station and actually can contaminate the entire system. So, that is the reason we will always like to see the actual highest flood level, and this is particularly true for sewerage networks, because otherwise the sewage from this particular pumping station will mix with the surrounding this overflowing water and spread everywhere. So, that is why we need to be careful about the highest flood level as well. And to do that, we need to do topographic survey and do floodplain analysis to understand what has been the previous instance of flood during a certain number of years, and based on that we also need to look into the terrain, and then we have to decide on is that a suitable location for setting up a pumping station. In addition to that, if we are setting up a pumping station near to a river, maybe we are like a intake, it's near an intake point, we also have to make sure that the river doesn't change its flow over the different season. For example, during dry weather flow, there may be changes in the course, and based on that we have to locate the this particular pumping station, and so that it is all throughout the year water is available even during peak demand, so that the location of intakes and location of pumping station is more or less synonymous in this particular aspect. So these are all basic criteria, plus there are other criteria which are some of these criteria is obvious criteria, but sometimes because of availability of land we decide on a pumping station, then we find all other problems, like for example, land is there but there is no power or there is no water, right. So you require water for both maintenance of the pumping station as well as for use by the people who would be walking there. Power is, of course, without power the pumps will not run. Then roadway access for certain removal of machinery, bringing in machinery you require, there has to be roadway to the pumping station. The surrounding land use, it's better not to have in a very dense residential area, so that in case there are some failures in the pump, again there will be flooding from the pumping station from that particular pumping station during any high rainfall event. There may be cases of flooding as well. And drainage that enables runoff away from the structure, so it should be at a little bit higher height so that the water flows out. And fire hazards, because these are all mechanical equipments running for long periods, there may be cases of fire, so we should be able to handle that. And size and type of pumping stations, operators' health and safety issues, particularly important for sewage treatment plants, and also visual impact and also impact due to odor, noise problems, and these are the things which we should be think or consider while we decide on the location of pumping stations. So next we talk about how do we set up these pumping stations. Like you can see, this first image is 500 million liters per day water pumping station is Bangalore. So you can see it's a large hall or a large structure where we have got several pumps. You can see there are multiple pumps which are aligned one after another, and similar kind of setup is seen in water pumping station is Kolkata, and there again you can see different pumps, and many pumps are there and they are connected to one line. What is this, why there are so many pumps, why it is connected to one line, I will explain later on. But first of all, we need to understand how these pumps are set up, means how it is connected with the supply lines or the exit lines, and at what level they are set up, that has to be understood. So pumps can be placed both below and above level of water in the sump well. So we have already known that first for any kind of water, it first comes to a sump well and the water gets stored. From there we have to pump the water out, right. So that is the basic thing. That means in any kind of pumping station you will find sump wells. So the pump could be either below this water level of the sump well. So that means it means at a level somewhere in the bottom of the sump well, or it could be also above that, right. Now as you can understand, if it can be in the same chamber as the sump, but it's usually kept outside. So if below the water level, pump is actually put into the adjoining dry pit. So that means usually there are two chambers. So one chamber is dry and one chamber is wet. Wet chamber is where the water comes in, and the dry chamber is where the pump is there. And it's connected to a common suction pipe. So that means you can see there is one pipeline over here. So it's this is one pipeline and this is a common suction pipe. So all the pumps are actually drawing water from there. Slice valves are used to isolate pumps. So we also in a pumping station we also have to use lot of valves as well. The reason is in case one of the pump has to be repaired, there are some faults. There are a lot of faults actually in pumping stations. You will see that pumps has to be repaired or overhauled at certain intervals, and then there are a lot of faults. Minor repairs has to be taken care of. So there are valves over, as you can see, this is a valve, this is a valve. Now, these are different kinds of valves are there. So, we will discuss about that, but these are used to actually stop the flow of water inside the pump, so that the pump could be repaired, and then again we can open it and then we can use it. Then priming is not required since below water. So, priming in certain kinds of pump, for the pump to operate, we need to first put water inside the pump, right. Otherwise, there would be air inside the pump, and because of and the pump will start rotating, and because of the air, no water can move inside the pump. So, to do that, we sometimes have to remove the air from the pump, and that is called priming of pump, and for that we have to put water inside first. So, in case the pump is below the sump level, so because of the pressure of water, automatically the water will get inside the pump when the pump starts running. So, we do not have to bother about separately putting water into that and priming it, right. So, priming is not required since it is already below water level. And finally, pump drive. So, the pump is there, but the pump is actually, there is a mechanism which actually does either rotation or some sort of movement inside the pump, and that particular mechanism or motor could be a electric motor, or it could be a fuel driven motor, whatever the case may be. So, this drive is actually at a higher level. So, it is not put inside along with the same. Sometimes it may be put there, but it is usually kept outside or at a above level, so that the chances of flooding and all is minimum. So, that is the pump drive could be at a little bit higher level, and as you can understand, the drive is the motor. So, to drive to rotate the moving mechanism inside the pump, there has to be a shaft connecting it. So, either the shaft could be horizontal if it is at the same level, or it could be a vertical shaft connecting this particular drive with the pump. So, it could be connected via vertical shafting as well. So, this is what happens when the pump is below the water level, but the pump could be also above the water level. In this particular case, the elevation could be as per the suction lift or limitations of that, and usually limited to 5 meters. So, we do not keep it too much high at a higher level, and pump drives are at the same level and horizontally coupled. So, in this case, because they are at the same level with the electric motor, they could be horizontally coupled together, right. So, it depends, there could be so many different kinds of arrangement, and that is actually shown in this particular image. So, we can see that there are 4 setups, and this is a typical dry well and wet well installation that we see. And the first one is a horizontal pump in dry pit. So, over here you can see that this is a dry pit, and this is the sump. So, this is sump, this is the dry pit, and this is the pump, this is the pump, this is the motor, and this is from where the water is being drawn inside, and then it is lifted by the pump and then sent over here, and these are the valves. So, this valve is given so that the water does not comes back, and there could be a valve also over here in the front to prevent water to get in. So, this is one setup, and from the you can see that from the top it looks like this over here. So, this is the section, and this could be the plan, and then we have got vertical pumps in dry pit. So, over here if you see similar setup, but the motor is above. This is the shaft, the vertical shaft which drives the pump. So, this is the pump, this is one valve, this is the second valve. So, this is the valve which prevents water to get in, and this is the valve which prevents water to get back in when the pump is not running, and this is the electric motor over there. And similarly, we can have vertical pumps in suction well. So, the pump itself is over there, and this is a dry well, and this is inside the suction well. The pump could be there, and the motor is outside, and the next one is a submersible pump in suction sump. So, that means the entire pump is actually submerged. So, there could be that kind of systems as well. So, there are different kind of setups that we actually see inside pumping stations. Now, when we set up the pumps within pumping station, as we are saying, we use different kind of valves, and these are used for controlling and modulating the flow. That means, sometimes we will prevent water to get inside the pump, or sometimes we will prevent water to get in, so for maintenance, or sometimes when the pump usually is not operated all throughout, So only in certain times of the day it is run. And then certain pumps are usually we have different, not one, multiple pumps. Sometime one pump is run, sometime another pump is run. So it's not every time the all pumps are in operation, but all these pumps are usually connected to the same pipeline, and that is why whenever one pump is stopped, it would always be the tendency of water to come back into the pump. And particularly if this is something like a centrifugal pump, you have to prevent the water to come in, otherwise the pump will start rotating in the opposite direction, right? Because of the pressure of water, the pump starts rotating in the opposite direction. So we have to prevent water to get back inside the pump, right? So for that we have to also use valve, and special kind of valves which allows water to flow in one direction, but it doesn't allows water to come back. So slice valves or gate valves are used for isolating pumps in the suction side. Suction side is the side from where water is drawn in, and butterfly valves are not used in the suction side. Now, what are butterfly valves? I will come. In the discharge side, check in that means where we actually send the water out, we use actually check valve, gate valve or butterfly valves. Now, all these three kinds of valves are where almost the principle is same, but they varies in design. Like you see, this is the check valve and the water flows in this direction, and over here you can see that this particular this arm, this whenever the flow is there, it is lifted and water can pass through, but when the flow there is a back flow, automatically this falls back and then water cannot get back into the pump. So similar kind of arrangement is there in the butterfly valve as well, and in other gate valves or check valves, all of them are more or less similar. And so this kind of valves prevent water from coming back inside the pump. Then pressure relief valves are used in the discharge side for flow control, pressure regulation, and to protect from surge pressures. Sometimes there are pressure buildup in the system for various purposes, right? So sometimes because of change in the size of conduits, sometimes whenever you stop pump, there could be certain cases when there is a lot of pressure that builds up into the system. There is something called a water hammer. That means the water starts moving inside very fast, and that actually creates some problems, and it may actually damage the pipeline. So sometimes the pressure is so much. So this is called surge pressure, and we have to protect the pipelines from there. And so for that we require pressure release valves. That means whenever the pressure exceeds a certain value, these valves are opened, and this extra water can get out. Then there is air release and vacuum relief valves are also used at the discharge side for vertical turbine pumps, and the reason is sometimes air gets inside the pipeline, and because of the air the water cannot move smoothly. So this is where the air release or vacuum relief pumps actually could release this particular air outside the system, and then the water can start flowing again. So these are the different kind of valves that are usually found in along with pumping stations and in different parts of a water supply network or water supply, or even in certain case sewerage networks. So this is in this particular image you can see the setup. So we can see this is the initially there is a screen, this is the channel from where this water is being drawn, and it could be a channel, it could be a pipeline from where, but we allow the water to get inside the sump well, and this is where we actually put a screen so that impurities and other larger floating matter and all should be prevented to get inside. The similar kind of setup is there in a sewage treatment plant as well, sewage lifting station as well, where we put in a screen and all to prevent similar kind of matter to get inside. And then because pumps are sophisticated mechanical devices, if you put too much amount of impurities or solid particles in that, they will break. So we have to the water that has to be pumped, or the sewage that has to be pumped has to be free of this all this larger or more bigger impurities. So from the sump well we have this suction pipe. See, there is a valve over here as well, through which you can actually stop the flow, and then from there we have a common suction pipe, and we have got multiple pumps connected to it, right? And each pump there is another valve. So these are the slice valves through which you can prevent. So I will just discuss over here. So this is the slice valve, and over here you can see this is the hand wheel through which you can actually rotate, and this is a sort of a screw which actually comes down and whenever you want it open, you rotate it and this screw goes up and water can flow. But in other times we can again rotate it and gradually this entire screw can come down over here and this can actually close the flow in the system. So, this kind of valves are actually put over here so that we can control the flow inside the pump, and this is our pump, and again we have got other kinds of valves over here so that we can again prevent backflow, or actually we use there is two valves. One is a check valve or butterfly valve, what you may call it, so that backflow is not there, and the other is a slice valve as well. So, slice valve to just again segregate this particular pump from the flow. So, this is the common discharge pipeline. So, one common suction pipeline and one common discharge pipeline. So, all the pumps are actually connected to that. Now, the reason is and along with that we also have this office, we have the switch rooms for turning on and off the pumps. So, this is more or less the setup of the system, and to build up surge, there is a surge tank. That means in case in the pipeline there is a surge or a pressure that builds up, this tank can take care of that extra pressure, right. That means that extra flow and all can actually be taken, sorted out over here. So, as you can see, why we are having so many pumps? The reason why we are having so many pumps in most cases, and this is called parallel operation, two or more pumps discharge into the common header. Header is that pipeline, and these pumps are likely to have the same cutoff head. And usually, most cases, the pumps, if two pumps are supposed to run in together, that means both these pumps would be operated together. They will have the similar head. Similar head means they will be able to generate same kind of pressure, that their ratings would be similar, right. So, that is the same. I will explain what is a cutoff head later on in the later chapters, but understand that cutoff head is the maximum possible that at that particular head we will actually the highest amount of pressure is actually generated. So, if we run two pumps together, usually they should have similar kind of ratings, but when we are designing a pumping system, there are two options. Either I have use a variable speed pump, that means because the amount of water that I have to send or discharge is actually different at different time periods. So, sometimes there is a peak, sometimes there is a a low requirement, and sometimes there is average or medium requirement. So, we would have to run the pumps at 3 variable speeds, right. But usually a variable speed pump is difficult, is costly, and the same time if you have one pump only, if it falters, you have to have another pump of that as the backup. So, instead what we do is we have normal pumps, but of different capacity. For example, to take care of this, we have two large pumps which will serve the max demand. That means it will be able to take care of the maximum demand, and one normal demand pump and one minimum demand pump. So, one of the max demand pumps is actually as the backup pump for all the situations. So, when there is high demand, we will run a large demand pump. When there is normal demand, we will run the normal demand pump. When there is minimum demand, we will run the minimum demand pump. In case any one of them fails, we will be able to run this maximum demand pump to take care of that particular water supply. So, we actually go for, so because we have got backups, if we design a system like that, so we have 100% backup or standby capacity of average demand and around 50% capacity of the peak demand. So, we design our systems in such a way so that there is backup capacity in case there is some failure and all. So, 50% capacity of the peak demand could be satisfied, and around 100% capacity of the average demand can be also satisfied. So, this is why we can have multiple pumps set up together, and even though they may not run all together, sometimes we can also run couple of them together, as we are saying that in parallel operation we can run them, and we can also supply water like that. So, this is how we set up these pumps. We also have flow meters. Flow meters are actually used to determine the amount of volume of water that is being discharged. So, we meter it at the pump end, and also we meter it at the house end or the residential end, right. So, when we add up all the residences and we also know how much amount of water is discharged, then we can actually determine what amount of water is lost in the system. So, in that way we actually have, that is why we have flow meters both at the discharge part in the pumping station as well as near in the houses as well. So, there are certain things like pump cavitation or surge or hydraulic transient or water hammers which we need to be aware of. So, pump cavitation actually when there is change in flow along in the pipelines, change in pressure, sometimes there are some issues that happens with that, the flow is disrupted and all, and so this is a phenomena is called pump cavitation, and sometimes there is surge or hydraulic transients which results in water hammer or moving of water at a fast pace in between certain zones, and that actually creates both a sound as well as the water doesn't comes out during that time. So, this surge or hydraulic transient is again because of some sort of suddenly you put off your pump and then the system actually the flow rate changes and sometimes the system get disbalanced, and then it will move in a unsuspected manner in different directions, and that actually results in these pressure differences results in something called water hammer, and that is why we need to take care of this kind of things in a pumping station. So, to conclude, pumps are required in both water supply and sewerage networks, and multiple pump setup is preferred over variable size pump, and this also ensures backup capacity. These are some of the references you can study. Thank you.